All right. Good morning, everyone, and thanks for joining us for the Fall Fish Monitoring Work Group meeting. A couple of housekeeping tips before we get started. Please mute yourself by clicking the little microphone. If you look at the screen that's up right now, it kind of shows you what that looks like. If you wiggle your mouse a little, that pop-up will sometimes come up on the top of your screen. And obviously, if you have questions or whatever, feel free to unmute yourself and ask questions or use the chat function to raise your hand or just type in the chat. If you're on the phone, please use *6. We are recording this meeting and it'll be available on our YouTube channel next week. And now if you guys could open up the chat and introduce yourself with name and agency, that helps us keep track of participation. Next slide, Sam. Thanks. All right, so on the agenda today, we have welcome and introductions. So hopefully you guys have figured out the chat. It's that little speech bubble. And just type in your name and organization. We'll kick off with the task updates, and then we'll transition to the tech talk, and then I'll wrap up and do next steps before we adjourn. Next slide, Sam. So let's kick this off with some updates from the 5 currently ongoing tasks. I will hand this off to Nancy for task 5.
Okay, you can go to the next slide. So task 5 is focused on bringing together different expertise from biologists that work with different resident fish or anadromous fish species. Our main focus are on the focal species that fall under the Fish and Wildlife Program of the Northwest Power Conservation Council, as well as species for which we have data sets at StreamNet at Pacific State. So we have Van Hare, who works with the GIS Center at Pacific State, and Evan Brown, who is one of our StreamNet partners that works at IDFG, who volunteered to co-lead this team, but I'm speaking on their behalf today because both of them have conflicting appointments, but they prepped me, so you're in good hands. So their task is focused on helping advance the population boundaries that we have at Pacific State that we then connect to our data sets, whether they're our GIS population maps or our data query tools that then display the population in question for which we have data sets supporting that given population. We already have a good set of population boundaries for salmon and steelhead population that are part of our catfish HLI, but this endeavor is now focusing on expanding that to other species that we have in our system or that we foresee receiving data sets in the near future. Van and Evan are focusing right now on developing a draft document that will kind of show the process that will be used by which we would bring in all the existing information from the different managers and bring them in together in a way that we can then sync them up to generate these population boundaries with, of course, the support of the managers for the end product, right? We would always go back and make sure we got it right. And their first trial fish species is bull trout. So they've been waiting and on U.S. Fish and Wildlife Service to provide them the population definitions that they have that would then inform the population boundaries for this task. They just recently received that GIS layer, so they're getting closer to be able to launch this task. And what they will be doing and the next steps during the month of October, now that most of Evan is back from the field and we have this new content from U.S. Fish and Wildlife Service, is finish setting up the document and the approach, and then setting up the first doodle so that the task members can get together and they can start having discussions on what's being proposed and how we would move forward to define new population boundaries for all the resident fish and other anadromous fish species for which we need these at Pacific State. So you'll still be getting an email from them, hopefully end of October. Any questions on this one? Meg, did I skip anything or are you good?
Nope, I think that sounds good. All right, next slide. And next is Mike Bannock.
Good morning, everyone. You can hear me, correct?
Yep.
Okay. Um, so we've got a task going on regarding the term smolt equivalence. In our juvenile out migrants table, the life stage of the fish to report varies depending on the species and around geographic area that it's for. Some of these call for smolt equivalence. Which is, and for those, it's bull trout, coastal cuts, coho, east side, stream type chinook, and steelhead. A couple of years ago at the PNAMP smolt numbers workshop, based on the amount of snickering we overheard around this term smolt equivalence, it became pretty clear that we needed to provide a better explanation in the DES for what this term means. With initial input from Dan Rodding and Lance over in Idaho, Casey and Russell and I, along with some others, have recently been attacking this problem. Our plan is to include an appendix in the DES with definition and several examples of different complexity to help people understand what's meant by this, so that people can understand when they're submitting data, can understand what's being asked for. While doing this, we noticed a couple very minor DES adjustments we think we're going to propose to make in addition to adding that appendix. So there's a place where we want to generalize the language a little bit. We're going to move the wording from one place or another. So nothing's really new related to this. Nothing's actually changed. We're just trying to make things clearer. We're adding explanatory information. Kind of also just working on this the last few days, realized that we also need to include a link to this explanation or the appendix, whatever, in the downloaded data so that people who receive the data too can know what the heck we're talking about. So kind of realize that that's missing also. So once Russell and Casey and I get our final thing done, which we're hoping is going to be very soon, we'll bring the proposal back to the Fish and Wildlife Management, Fish Management Work Group task team for review and input. After that, we'll go to the DDT, make a proposal for this change, and there it'll also be reviewed and maybe perhaps improved further, or maybe they'll just say, yes, that looks great. Just to make sure everything is accurate and fits with real data, and everything fits with other parts of the DES. Just we do a lot of review to make sure everything's good before we jump. A second topic, Russ Granton at BPA has also had some frustration and spent too much time trying to figure out where outmigrant estimates are made relative to the geographic boundaries of the population. Therefore, so are these numbers of smolts or whatever, are they when they leave the population boundary? Are they for somewhere inside the population boundary? Are they someplace significantly downstream of the population boundary, like Lower Granite Dam for a lot of them in the Snake Basin? We're again, the three of us, we're going to, and working with some others, we're going to propose to the DDT a new field to classify where these outmigrant estimates are, just so when a user gets it, they can better understand exactly what they're looking at. This item needs a bit more thought. With the smolt equivalent explanation, we think we're just about there. This one we need a little bit more thought on before we bring it out to a broader group. But we're pretty close in this one too. Third thing on our slide here, discuss the February 2021 survey results. I'm going to leave that to others who know this better than me. So Jen, Nancy, could you say something intelligent instead of what I would say?
All right. I'll do my best. So I think it goes back to a year and a half now, where when we started having discussion about how can we improve the content of the data exchange standards is being used to exchange high-level indicators at StreamNet under the Coordinate Assessment Partnership's Fish HLI data query, we decided to take a step back and not only focus on the items that we knew that had been brought up, such as the smolt equivalent issue through that workshop, but to actually reach out a bit more broadly to those participating in the DDT to get a sense of what else maybe needs to have further discussion so that we can improve the data exchange standard content for all of us. So we mainly Mike and Jen and I, supporting him as needed, developed this survey by which we actually sent out to the DDT and asked them for each of the section, for each of the tables in the data exchange standard, where did they see a need for us to further dive in, either improve the definition in there by working with the biologists, or maybe it's just something that was more of a tweak for the data managers to understand better or to adjust the validation rule. Where did they see a need? So we conducted that survey and compiled all the input. Some of it was even like redlining the actual data exchange standard tables, but we started summarizing that, and from that input, we identified a few items that might be beneficial to bring to the fish monitoring work group to get further input from a broader range of biologists that works with these data. So those are the ones, as we get done with these first tasks that Mike identified, we'll be looking at that survey and seeing what else needs to be brought forward and discussed with the fish monitoring work group. So more to come. So it's the one task team that will just keep probably generating follow-up tasks as we keep uncovering new items that need further discussion. Jen, is there anything else you want to add to that?
No,
I think you're busy with the chat.
You said it very well. And yes, we're having a little issue with the phone number for the conference number, if you're following the chat. So if someone's trying to use their phone and just listen in that way, it doesn't seem to be. But Nancy, you did a great job of summarizing the purpose and next steps with that survey. And though Mike has already put it out of his mind, he's going to help us understand those results, because it was a little while ago. So now we'll come back around to it and take a look and see what part might come back to some of this audience as biologists, or what pieces of that might be put in front of the DDT data managers team.
All right, excellent. So Sam, if you want to advance the slide. All right, next up we have the carrying capacity data standard with Morgan Bond from NOAA.
Hi, everyone. Yeah, Morgan Bond at Northwest Fisheries Science Center. So I recently joined this task with Tim Copeland and Russ. And so, I think this is sort of a reintroduction of this idea that came up earlier. But carrying capacity models and estimates have really proliferated in recent years. And there are many models producing lots of estimates at different spatial scales. And so this really seems like an ideal topic for some type of data exchange standard and guidance, really, for people that are trying to either create these types of estimates or use them. And of course, carrying capacity as an idea means different things to different people. When you use that term, that can certainly have different connotations depending upon what people are doing. But there is this natural inclination to want to use something like capacity because it provides this benchmark with which we can compare different scenarios of restoration or management. So we think that there's really an ideal opportunity here to pull together information about all the different types of models and inputs that people are using to create these models, as well as the types of outputs, because we do get different types of outputs and different models. In addition to that, these models are operating at different spatial scales. So some models are operating at the population scale. Others are really more reach-based or site-based models. And so we have an opportunity here to try to alleviate some of the maybe confusion or misunderstanding around how these models could or should be applied. And so our sort of first product here that we're talking about is really just some guidance about what these different types of models are, and how they're created. Can we go to the next slide here? So the outcomes that we'd like to see, again, as I mentioned, we'd like to see some guidance for, how we think these types of outputs from capacity models really should be used, when it's appropriate to use these estimates. And then really we've separated these into two kind of broad categories. And one is estimates at the population scale, and then estimates at that site or reach-based scale, because we have pretty different models trying to do pretty different things at those two very different spatial scales. Those models often have very different inputs, and those estimates are outputs are at different scales as well. So we'd like to come up with data exchange standards for those two sort of broad classes. But then within each of those, there are of course different types of models. And so we'd like to see is some good advice and documentation for all of the different inputs that go into these models, many of which are parts of other tasks, things like juvenile abundance estimates and whatnot. So we'd like to see good documentation of that, as well as the types of models and methodology that goes into those models. And then finally, of course, the outputs and the types of outputs that people are producing with the various models. Can we go to the last slide? And so Russ has put together a draft data exchange standard that's really just sort of the starting point that we'd like to see, just getting going on this. So what we really need is for folks that are interested in this to join us and provide some input as we move this forward. And so our big challenge now is to get the next meeting on the books where we can get sort of maximum participation from people that are interested in this topic, and then start getting input from all the various user groups or model producers for these things. So where we'd like to go next, is to get people to sign up, basically. And so I think we're gonna have a doodle poll that's going to go out soon, so we can try and find a meeting time that's going to really maximize participation. So I think keep an eye out for that. Is all we can say. We're not actually sharing. Yeah, please, if you want to jump in.
We have a doodle for this task team, and what we're going to do, that doodle's ready to go, but we decided not to throw it out there today because there's a couple other tasks that are about to have a doodle ready. So what we'll do is put together a follow-up email after this meeting that will go out sometime next week. And it will say, here's task 9. We have a short description document. That's a little screen snip there. So I'll give you a link to that and then a link to the doodle. So people, later on, you can say, oh, what was that task I was interested in? Here's a little description about it. And here's a doodle for the first meeting to participate. So we'll put that all in one email instead of having them go out one at a time.
All right, excellent. And Tom, we'll get you on the carrying capacity list. Next slide, Sam. And next up, we have Casey presenting juvenile density data standards.
Hey, good morning. I'm going to just present a little bit here real quick about the juvenile density data standards and proposed data exchange standard. Kind of similar ideas as carrying capacity. Juvenile density and distribution data is widely produced and used across the region with varying degrees of spatial scales and locations. And there's been a need identified amongst data users and by Russell for a need for kind of some better understanding of what is in the density data, how to use it, how it can be applied. And so the purpose of this group is, to develop and propose data standards and a DES for this distribution and density data from snorkeling and electrofishing. And there aren't any current data standards or sharing systems in place. And these are often spreadsheets that are sort of shared across organizations. And so we're looking to kind of provide some of those data standards and, documentation on proper use, just as Morgan sort of talked about with carrying capacity, very similar. And so, our products, again, data standards and the data exchange standard, documentation, and then recommendations for where, for data management and sharing systems. So, there's potential that data shared and, following these standards and in this exchange standard could potentially go to, StreamNet data store, be incorporated in there. Russell, again, has put together a data crosswalk and a draft exchange standard, which you can kind of see that tiny snip. Don't try to look at that too closely. But he has a draft there. So our next steps is Russell and I will work on sort of finalizing this draft and the crosswalk and documentation. And we'll schedule a task team. So this is really our pitch right now. If you're interested in being involved in this, please let us know so we can add you into this group. And as Jen mentioned, this will be one of the tasks that will be upcoming with the doodle here pretty soon, and we'll go out there. Once we have an idea of the additional team members that would like to join, we'll share the draft products that we have, and look for participant feedback. And hopefully, we're looking to maybe hold this first task team meeting December-ish. So yeah, let me know, let Russell know, let Meg or Jen know if you're interested in joining this group.
All right, awesome. Thanks, Casey. Next slide, Sam. Next up is rotary screw trap data collection data standards, and Polly is going to present this one for us.
Okay. Hi, everybody. I'm Polly Gibson. I work for Oregon Department of Fish and Wildlife in the Grand Oregon, and I'm currently one of the leads for the task to develop some data exchange standards associated with rotary screw traps. So lots of us in this meeting work on monitoring juvenile salmonids with screw traps or methods like that. But of course, we all do it a little differently, or a lot differently. And even just trying to compare our data collection methods and our data analysis methods among projects is, of course, really difficult with all the different ways that everyone is managing their data. So with this task, I think part of the goal is to enable us to compare analysis methods or apply a common analysis method, like for estimating abundance, on different people's data sets from different rotary screw trap projects. And then, of course, more generally, to make all the data all that effort that we spend collecting that rotary screw trap data, to try and make that data more usable to people outside our immediate organizations and programs. So progress that we've made so far on this task, this is all going to sound really similar to the last few tasks that gave updates, but we've developed a draft purpose statement and a list of products that we want to come up with. So specifically, the outcomes that we're imagining right now is 3 related data standards. One of them for trap operation information, like how long your trap was running or when you missed days and that kind of thing. And we'd like to have a data standard for ways to document fish condition for the fish that we catch in those traps. And then finally, and this is going to definitely be the most difficult piece of the standard, is coming up with standard ways for how we share information for estimating trap efficiency associated with our traps and total fish numbers that we caught. Next slide, please. So then the other bit of progress on this task that we've made so far is we're currently, again, working on developing a rough concept data standard at this point, just in the form of a crosswalk among the different data fields people are collecting. And again, this image shows part of what that looks like so far, not that you can probably read it from here. So next steps for this task are basically the same as for the previous tasks, again, that have been presented. So we're aiming to have a meeting sometime in December or maybe January to start getting feedback on these products. So we will again be sending out a doodle soon to interested team members to try and find a good time for that. So keep an eye out for the doodle. And then also prior to that meeting, we we'll be sending out a rough draft of this concept data standard and the other products so that people can review it or add to it if they want ahead of that meeting, and also to give us something more concrete to work with when we get everybody together. So yeah, I look forward to talking with many of you soon. Oh, and again, let us know if you're not already part of this task, but you want to be. Thanks.
Awesome. Thanks, Polly. Next slide, Sam. So next up is our tech talk. I'm going to hand it over to Casey to introduce our speakers for today.
Hi again, everyone. Yeah, I get the pleasure of introducing our tech speakers today. We have Neala, Kendall, and Thomas Buhrens. Neala has been a research scientist with the Washington Department of Fish and Wildlife since 2013 and leads the statewide quantitative synthesis and reporting unit. Among other projects, she conducts research on salmon and steelhead, marine survival, and life cycle modeling, and she helps with status and trends reporting tasks. She is currently growing her team to take on more projects related to better estimating salmon and steelhead escapement. And Thomas is also a research scientist with Washington Fish and Wildlife since 2012, and he leads the Lower Columbia Science Unit. His work focuses on estimating demographic parameters for salmon and steelhead populations, including designing and leading programs for the Lower Columbia region and statewide to estimate smolt and spawner abundance, fishery encounters, mortalities, forecast run sizes, and model population dynamics and viability. And we are really excited to have these two here today to talk to us. I'm very personally excited to hear what you guys have to present. So thank you for joining us.
Yeah, thank you so much, everybody, for having us. Can you hear me?
Yes, I can hear you, Neala.
Okay, great. So yes, so can you click to the next slide? There we go. Okay, so Thomas and I are excited to be here today to talk about an overview of our WDFW state of salmon analysis. So this is from last year, 2020. This report comes out every 2 years, and we want to acknowledge also Scott Betcher, who also put a lot of work into this project. And that is the website, thestateofsalmon.wa.gov, of the big report. So if you go to the next slide. So the goals of the State of Salmon report, and I want to focus here that Thomas and I did a part of this report. And so if you go to that big website, there's a lot of information about not just status of salmon, which is this part that we worked on specifically, but Thomas and I here are talking today about a part of the State of Salmon report, which the goals of it were to report on status and trends of specifically ESA listed salmon and steelhead in Washington State, and also categorize the overall conservation risk for each of the listed ESUs and DPSs. And so there's a lot more information about salmon and steelhead, but this is just the part we're focusing on of this report. So next. So process and roles. We wanted to kind of go through this to kind of show that this was not just a WDFW effort, but we really appreciated a lot of feedback from many of our partners. So for the first step we did, step one there was, this is the science stage. And so we're going to get into obviously a lot more details about the data analysis and everything. But the point is that WDFW, Thomas and I in particular, with obviously a lot of input, a lot of data, a lot of help, led this status and trends analysis. And then after we produced our results on the conservation risk, it went to our salmon recovery partners, and then they had some input about obviously on the ground knowledge. And then from there, it went to GSO characterization and categorization. So, and that produced the final adult abundance risk categorization chart. So anyway, the point is that this was not just completed as a science exercise. It was definitely a large exercise. We appreciate our partners. Next. Okay, so here is our data slide. So we're going to go through here. So we preferentially, so where did we get our data from? Where did we get all the data on all the salmon and steelhead? So we preferentially use coordinated assessment. So obviously we're very, very grateful to many of you on the call, and obviously tons and tons of partners who have worked so hard to get data into coordinated assessments and make coordinated assessments, organize coordinated assessments. And it's because of all this work that we're excited to use coordinated assessments, the data in coordinated assessments, because they were from, better field definitions. So for example, our goal was to use natural origin, naturally spawning fish, because the NOAA recovery goals are specific to natural origin, naturally spawning fish. We're so grateful that that is very clear in coordinated assessments. So we can also verify if the data were measured at a population scale. So what we mean by that is that it wasn't that it was an index of this is let's say we went out and we measured these 3 index reaches of the main stem. And but in coordinated assessments, it says, you need to extrapolate that to account for the entire population. So we're grateful. That's obviously really important, because if you're going to compare your data with recovery goals, the recovery goal is for the entire population. So you need to make sure your abundance is for the entire population. Also, coordinated assessments identifies best data sets. There's sometimes, different groups measure abundance or other metrics. And so it says, yes, this is the one to use. That was super helpful. There also can be, measured in different ways. And so that was really useful. And again, it aggregates across agencies. So obviously, again, so many people from different agencies on this call. And this is not this effort, it takes all of us to get these data. Next. So secondarily, we use WDFW Score, which Score is our website that you can visualize the data. And it used to be called SASE, and now it's called SPI, Salmon Population Index. And so when coordinated assessments data were not available or they were not complete. And so WDFW has worked really hard to, to have our database and to have people buy in, have our biologists buy in and enter data. We are, making progress to try to have this, be like coordinated assessments or, buy into coordinated assessments. But, this is a process, as many of you know. And so when the data were not in coordinated assessments, we got them from our internal WDFW database, and we had to do a lot more cleaning. Next. So we needed more examination of the data, and specifically Puget Sound, Olympic Peninsula, and Southwest Washington, ESUs and DPSs are not in coordinated assessments. So we needed to take those data from SPI. Next. Okay, data filtering. So we, first of all, obviously only wanted ESUs, DPSs, and specifically DIPs when an ESU or DPS goes across the state border or to Canada. We obviously only took the ones in Washington. And then next. So we wanted to, I talked a little bit about this earlier, but we wanted to ensure the population's abundance data applies apples to apples with recovery goals. So for those of you who are very knowledgeable with coordinated assessments, PopFit is same or multiple. So that means that it isn't a portion of the population, it's the whole population that the abundance data are representative of. Next. So yeah, so we want to use the best data set. So best value equals yes. Next. Okay, so this is, we wanted natural origin, naturally responding data. So again, as opposed to hatchery or mix. So the priority order we wanted was the NOSA IJ, including jacks, NOSA excluding jacks. And then for some populations, we determined we could use TSA, total spawning abundance, including or excluding jacks. This took a little bit more because sometimes, it's hard, for some, like steelhead, it's really hard to really determine if it's natural or hatchery origin because you don't see very many fish. You can't look for, adipose clips or whatever. So how do we know if total spawning abundance is natural origin, naturally spawning? We determined when it was not appropriate because the hatchery proportion was non-negligible. So if we know that there's a hatchery population, we know that there's strain onto the spawning grounds, we would not use it in that case. Next. Yeah, so the final data set included the years from ESA listing through the present. And so we did this specifically because our goal was to, again, look at ESA listed ESUs and DPSs, and we wanted to say kind of what's the status since that listing occurred. So this was a judgment call, but this is how we made it. This also aligns with other efforts to look at status and trends, such as the Results Washington, the Puget Sound Partnership, vital sign indicators, and some other past reporting efforts. So I'm going to turn it over to Thomas now.
All right, thanks, Neala. Yeah, so the data analysis that we used, in the past, the state of the salmon analysis has not been a super quantitative analysis, and we were very fortunate to be able to sort of stand on the shoulders of giants because NOAA Fisheries, Eli Holmes, and a lot of collaborators have done a great job of sort of pioneering status and trend assessment methods for listed ESUs. And rather than sort of reinventing the wheel, we really wanted to start with the good work that they've done. The other thing is, I think the approach that Eli and collaborators have developed is flexible. It can make use of data, data sets of varying lengths with a lot of missing data. So we thought that was really robust. And so what that approach is sort of a state space model that fits a log normal random walk with trend to each population. And it does this in a multivariate framework. And so in the analysis done by NOAA for the 5-year status reviews, they test a couple different candidate forms of this model where the process error variances and the observation error variances are either allowed to be the same among all populations or independently estimated among populations. And the trends are independent among all populations in all of their analyses. And we did something slightly different where basically we treated those observation and process error variances as random effects among populations, which basically allows the data to tell the model sort of how different or how similar those are, and allow more data-rich populations to inform more data-poor populations, both in terms of those process and observation error variances, as well as the trend components. And then finally, the covariance matrix for the evolution of the basically the population trajectory through time. In the NOAA analysis, that was basically either fixed, so there was sort of one among population correlation, or they were all independent. And for our analysis, we use what's called the LKJ prior to allow the correlation matrix, which is the among population pair correlations in their process evolution, to be sort of hierarchical. So sort of letting more data-rich populations inform more data-poor populations about the level of correlation within populations in an ESU. And so that's a verbal description. I'm not going to put up any more equations. I just wanted to describe that, and I'd be happy to go through more details with anyone interested. But what this model generates is an output, which is an estimate of the smoothed abundance for each population in each year, even years where there's no data available, as well as an estimate of the trends for each population since ESA listing. Next slide. All right, so this is just orienting you to an example of the output of one of those models. So in this case, we've fit the model to the Mid-Columbia River Steelhead DPS to the populations within Washington State. And so you can see the data as dots on this graph for the observed natural origin spawner abundances. And then you can see the smooth lines going through. And so a couple things to point out. The first thing is that smooth line is generating abundance estimates even for years where there are no observations for that particular population, which is really helpful for kind of making apples to apples status and trends comparisons over a uniform set of years. The next thing is that you can see that for some of the lines, the line follows the dots nearly perfectly. And so those would be populations where the model is intrinsically determining based on the data that basically there's very little observation error here. The model thinks this is really the biological process, and so it's gonna really tightly fit those data points. And so good example would be Sadis and Toppenish Creek at the bottom of the graph. In contrast, at the top of the graph, you see the Klickitat, where the model basically says, oh, it looks like there's a fair amount of observation error. And so the smooth trend is not quite hitting each one of those data points because it's basically assuming that there was more observation error in those years. So anyway, and then once we've fit that model to all the data points, we can then say for each year where the smooth abundance was relative to the recovery goals, which are shown as that horizontal dotted line. And we can also then calculate things like the 5-year geo mean off of those smoothed abundances to compare with those recovery goals. And then not shown in this graph are those trends that sort of drove those long-term trends that were estimated, but they were an essential part of fitting these lines to those data points. Next slide. And so once we'd fit those trend lines, we were interested in basically deriving a series of sort of performance measures that we could assess the status and then the trends of populations, and then eventually figure out what their overall conservation risk was. And so the first way we did this was basically to look at their population status and basically look at the 5-year geo mean as a percentage of their recovery goal. So next slide. And so this is just an example for the Lower Columbia Chinook ESU and the Mid Columbia Steelhead DPS, where basically we've taken those 5-year geo means that you could see calculated from the smooth abundance on that previous trend chart. We've then we've taken the most recent 5 years, the geo mean of that, and then we've divided that by the recovery goal, and then multiply that by 100, so we can get the 5-year geo mean percentage of the recovery goal for each population within the ESU. And then they're just sort of sorted from high to low with populations with no available data at the top. And so looking at these two examples, you can basically see that for Lower Columbia Chinook, a couple populations above the 5-year geo mean is above the recovery goal, and a couple for Mid Columbia Steelhead, but many populations sort of falling short. And then many populations either don't have any data available or don't have data available that met those filtering criteria that Neala described a minute or two ago. Next slide. So the next thing we wanted to look at was what's the trend, increasing or decreasing since the year of listing. And so when you fit these log normal state space models, the slope from those models, the slope term, you can exponentiate it, subtract 1, and then that slope term is then interpretable as a % change per year since ESA listing. And so we created a visualization for the trends as well. Next slide. And so basically, these are % changes since ESA listing. Again, looking at Lower Columbia Chinook and Middle Columbia Steelhead. And basically, we can see that for Lower Columbia Chinook, the model's best estimate was that all the populations had been declining since ESA listing. For Mid Columbia Steelhead, it was more of a mixed bag with Upper Yakima main stem steelhead increasing, while there were a couple populations that were barely changing, and then some that were decreasing more. The other thing to notice is the different scales on the x-axis here. So for the Chinook populations, it looked like they were decreasing faster. For those Mid Columbia Steelhead populations, though more of them were decreasing, those % changes per year are really close to 0. So those are relatively stable populations overall. And those are point estimates, so that's not even accounting for the uncertainty in what that trend is. And one of the nice things is by doing this analysis in a Bayesian framework, we were actually able to quantify the uncertainty. In a lot of cases, with these short time series, the trends were quite uncertain. Next slide. And so then the next task we were given, and this was an interesting one for Neala and I as scientists. So we fit this model. We can say what the status is. We can say what the trend is. And what policymakers want is, well, how do you combine those two things? What's the overall risk to the populations? And so this was something that we wrestled with quite a bit. And so the first take that we had was, what if we just kind of plot these things on an XY plot? And so that's exactly what we've done. We've plotted each ESU. So the points here are the median population in that ESU's trend and the median status, so geomean % of the recovery goal in the most recent 5 years. And so you can basically plot that ESU's centroid, and then you can put the lines are basically the interquartile range, and then actually it might be the 90% range for the populations, and then the outliers are very faint dotted lines on this graph. And so then looking at that, you can get a sense where that ESU lies. And so we can kind of intuitively say, well, if your ESU is increasing in abundance and it's above its recovery goal, that's really good. So that's in the blue. And if you're both decreasing and below your recovery goal, that's in the red. But like, what if you're increasing but below your recovery goal, so top left, or what if you're decreasing but above your recovery goal, bottom right? How do we say which one of those things is more important for your overall status? And so we wanted to kind of go beyond this. Next slide. Actually, before I go on to the way we went beyond that, one thing that we noticed is that because the percent of the recovery goal, can go up to theoretically thousands or 10,000s of percents, but can't go below zero. It's log normally distributed. So we also revisualize this on a log 10 axis so that the populations that have really low status, it kind of shows a little more separation. And so visualizing it this way, you suddenly realize that like Puget Sound Chinook are down there at about their geomean percent of the recovery goal is around 3%, which on the last graph probably didn't look like that different from, say, Upper Columbia Steelhead, which actually is at more like 30%. And so that's where using that log 10 scale was helpful in terms of visualizing this for us. Next slide. And so in trying to figure out how do we combine status and trend, we realized that if you don't care about the future and you just care about right now, then the status relative to the recovery goals is really everything. You don't need to worry about trend. On the other hand, if you take any one of these trends and you project it out long enough in the future, even a population that's at a tiny percentage of its recovery goal, applying enough years of an increasing trend is doing great. And a population that's above its recovery goal, applying enough years of even the slightest downward trend is doing terribly. And so you kind of don't want to weight things too heavily towards trend, nor completely ignore trend, because two populations that have the same status with trends in opposite directions, clearly that matters. And so we were trying to think, well, how do we blend these two sources of information? And where we arrived was coming up with this kind of blended overall conservation metric called future status, which was the projected status of the ESU after applying 5 years of the median growth rate, basically with annual compounding to the median status in the last year of data considered for this, and then recalculating that ESU's percent of its recovery goal after 5 years. And so that was kind of a way of blending those things. And why 5 years? Well, that was after consulting policymakers. One of the things that we realized is a lot of the decisions that the Governor's Salmon Recovery Office and other salmon recovery practitioners were interested in, a lot of those were on sort of 5-year time steps. That's the kind of time step where you might reallocate funds, you might reprioritize efforts, that kind of thing. So next slide. So taking a look at that, combining that future status and trend, I have again the 5-year geomean percent of the recovery goal on the y-axis and the trend since listing on the x-axis. And so you can see the crosshatches are basically demarcate those 4 quadrants that I showed on the previous plots. But now instead of coloring things just sort of good, bad, and white, meaning one of each, what we've now done is we've colored based on where each one of those ESUs would be projected to go if its trend, if you apply its trend for 5 years into the future. And so we can then draw isoclines onto this graph. And so the white isocline at the top, that's basically now where you'd expect populations to, so that would be a status of 100% of your recovery goal after applying your growth rate for 5 years. And so if you have a positive growth rate, you can be at a lower status right now and still be at greater than 100% of your recovery goal in 5 years. And if you have a negative growth rate, you have to have a status above your recovery goal right now, just so you can stay above it after 5 years of declines. Next slide. And so similar to the last set of plots, we realized that, again, visualizing this in log space is helpful for sort of separating out some of the populations. And so when you do this, what you basically realize is there were 3 ESUs that ended up in the top right: Lower Columbia Steelhead, Hood Canal Summer Chum, and Columbia River, and then Columbia River Chum. And there were a couple populations in the bin where after 5 years of their current growth rates, you'd expect them to be between 50 and 100% of their recovery goals. Several that were between 25% and 50%. And then unfortunately, several that were nowhere close to recovery, you know, well below the 25% isocline. And one thing to note for these plots that I probably should have noted when I started is that, you know, we felt more confident in placing these centroids and uncertainty intervals for each ESU on the plot when we had a lot of data for those ESUs. And so those are the points where you see a dark blue circle and lines. For some of the ESUs, so take, for example, in the top right there, Columbia River Chum, we only had data for 4 out of the 10 populations available. That's what that N equals 4 out of 10 is. And so we chose to color that with a hollow circle and no sort of quantiles, because we really don't have a confident assessment of what the centroid for that ESU is. Same thing with Puget Sound Steelhead down in the lower left. Next slide. And so now, so basically, that was our quantitative attempt to basically combine, to take this formal trend analysis and sort of say, what is the current status, what is the current trends, and what do these things mean for sort of an overall risk category? So now Neala is going to take it back from here, talk about data availability, and talk about the process of translating this quantitative analysis into sort of an overall assessment for the State of the Salmon report.
Yeah, so I mean, Thomas led in this well that we did not want to hang our hat on the assessments, excuse me, for the ESUs and DPSs with minimal data. I mean, for example, Columbia River Chum, the 4 of the 10 populations were measured, and hey, it looks like those populations are doing well, but guess what? The other 6 aren't measured because there aren't very many fish there. So that's a good example about why we don't. So we set a threshold. We set a threshold of 60% of populations needed to have usable data in order for us to really feel like good about our assessment, our risk categorization. And so this kind of dropped out Puget Sound Steelhead and Columbia River Chum. So this is, again, obviously the population, the ESU DPSs are at the bottom, have 1 or 2 or 3 populations per that ESU or DPS, but there's a lot of missing data. You can see there for Puget Sound Steelhead, I mean, 18 populations did not have usable data, and this is a challenge. This is not to say that our area and district biologists are working their tails off to try to get these data. Like these are summer populations that are just, we really know so little about them. It's hard to get data on steelhead. A lot of times we actually have some data, but they haven't been extrapolated to the whole population. And so anyways, there's definitely some area for improvement in this specific topic.
Neala, can I make one more comment?
Yeah, totally.
Can I make one comment on that slide? Sorry, I wanted to add in for this group in particular, I think we really want to emphasize this data availability slide, because without the pop fit field that is available in coordinated assessments and the efforts of this group to really focus and hone in on that question, we wouldn't have been able, I mean, that's one of the major things that's being reflected in this data availability slide, because a lot of them, there was some level of monitoring. It's just we couldn't appropriately use them to compare with recovery goals since they weren't monitored at the population scale. And many status assessments in the past have made
including
that kind of comparison.
5-year status review.
Right, because they just didn't know, and there was no way to demarcate in the data that it wasn't monitored at the population scale. So really just emphasizing how important that really is. I'll keep on going, Neala.
Yeah. So I mean, you'll see differences like in NOAA's 5-year status review when they when they don't use coordinated assessments, so for those three ESUs, DPSs, I mean, you will see different results than we have, because they did not, you know, this is a tricky one to be able to say how, you know, to really have to know the data super well. And that's what's so wonderful about coordinated assessments, because you make it so that people can use data without having to know it super well. Okay, so next. Okay, so the final categorization. So remember back to Thomas's slide with the kind of the bands, that, you know, the 75 to 100, you know, 50 to 75, and so forth. So basically we use those categorizations. So we have that red in crisis. So future stat is less than 25% of recovery goal. And then we have not keeping pace, making progress, and then approaching goal. And so you can see there in particular, Puget Sound Steelhead, we put it there, but it's gray with a star because we don't have enough data. And again, Columbia River Chum. I also think it's important to point out is that the Puget Sound Chinook and Puget Sound Steelhead recovery goals in particular are much higher than recovery goals for many other ESUs and DPSs around the state. And I think a lot of times people recently I've heard recently that one reason why this maybe is because of, you know, the co-managers and fishing, and so we want to include get status back to healthy and harvestable. You know, what is recovery? I mean, that's just such a subjective thing. And so a recovery goal, they're not the goals themselves are not always they're made by different groups in different areas. So you know, that again was a policy decision. And so, but our point is that we used what was available in the recovery goals. So anyways, you can see that we have a lot of populations there in crisis and not keeping pace. And we have some populations approaching their goal, which is awesome. So this is what the WDFW, for our science part, produced. So next slide. So then these are the categories. And then again, the regional recovery organizations, GSRO, other partners, you know, came in and looked at this with their on the ground knowledge and evaluation and said, okay, well, actually, we don't agree on 3 of these categorizations. So you can see how Snake River Fall Chinook, Columbia River Chum, and Lower Columbia Steelhead, they were moved from our initial placement there, step 1, to a different place. Thomas and I agree with Columbia River Chum placement. We don't necessarily agree on Snake River Fall Chinook and Lower Columbia Steelhead, but again, you know, this is a group effort. And so if we go to the next slide. Oh, actually, so anyway, sorry, let me just wrap that up on this last slide. So anyways, this is where things settled out on the left after we had the final placement. So that figure is the final placement, which is what you'll find on the website. Go on. Okay, so part of our goal here, and we at WDFW are really trying hard to move towards reproducibility of our analyses and also kind of optimization when possible. You know, this was a lot of work. Thomas in particular worked his tail off on all the analyses, and he wrote it in GitHub so that we can really try to, you know, pull the data automatically from coordinated assessments and maybe trying to get there with SPY, but and just do these analyses. And so it's less work in the future, and so, you know, it doesn't rely on one person spending hours on the computer. And so Thomas's code there is on his GitHub repository. Next. So links, there's the GitHub repository, the full WDFW report is there, and then so that's the specific to our part on the status and trends there in the middle, and then the full State of Salmon report link there. Yep, so thank you for putting that in the chat too. Okay, so future directions brainstorm. So this, I'm hoping we'll have time to talk through these, because we obviously I think we mentioned some of these as we went along, but we think this is exciting stuff, and it seems like this group obviously is on the forefront of a lot of this. So standardization of status assessments across agencies. I mean, you know, like we're really trying to push WDFW to try to get our our regions, you know, are those regions that are in SPI. I mean, this obviously has a lot to do with, we have to coordinate with our tribal co-managers, because, you know, a lot of these data were collected by them, and we agree with, we worked, our district and area biologists worked to agree with our tribal co-managers on these data. And so the final evaluations of these numbers. And so it's definitely, you know, not just a matter of getting your data in. It's a kind of an agreement among partners. There's also some methodological innovations. So we could, you know, Thomas can go into lots of details about, you know, using different, you know, spatial structure, using different, you know, medians, and then using, anyways, details there that Thomas could talk about if people are interested in. Also, this again is just abundance. So we did not include the other 3 VSP, NOAA VSP parameters. You know, that's great. It's so awesome to hear at the beginning of today's meeting about how you guys really are trying to get more data into coordinated assessment so that we can use, you know, we can evaluate populations on different metrics. So that's really exciting to hear about. And then there's that transparency and reproducibility, you know, democratizing access to data. Again, I think that we've had a number of conversations about this, and I think part of this goes back to, you know, like people need to have trust that you're going to use their data well. We're really working hard to discuss this with our co-managers and accessing data. So raw data, you know, accessing data that have been, you know, raw data versus stuff that's been, you know, kind of, you know, put through a model to get a, you know, a index abundance, and then put through a model to go from index total population, you know, making sure these, you know, we're doing that in a consistent manner. That's actually one of the things that we are growing within my unit, the statewide quantitative synthesis and reporting unit, where we've hired a couple of new research scientists who are going to be working really hard to take this on to improve our methods of estimating adult abundance, and keeping, you know, these kind of standards in mind in terms of reproducibility and access and optimization when possible. Thomas, anything to add here?
Yeah, I guess the only thing I'd say is I think one of the big thing here, I'll sort of circle back to where I started on the analysis slides, which is, as I said, we were standing on the shoulders of giants because NOAA really pioneered some great methods for doing this, pioneered some of the original databases in the Northwest to aggregate across agencies salmon VSP parameter data. And yet at the same time, WFW and many other entities we have a need for internally and at a state level to do assessments of status and trends. And so I think there are really opportunities now for collaborating and trying to as a group identify common methods, common data sets, and trying to call the raw data directly from the raw abundance measures data directly from CA and have reproducible data filtering algorithm was really kind of an important piece to us, because I think one of the reasons status assessments have often landed at different outcomes is you get down to the most granular data, and despite best efforts, people just don't end up with the same numbers. And so trying to move from the more analog ways of collecting and aggregating that data in the past to sort of reproducible data filtering algorithms, I think it would be a great thing, and it's something that we hope to work more with our NOAA partners on in the future. So with that, thanks for inviting us today. And I think our next slide, I don't remember, but it might be just opening things up for questions. This is an extra slide, so maybe go back and we can leave it on the brainstorms while we take questions.
All right, excellent. Thanks a lot, guys. That was a really fascinating presentation. It clearly took a lot of work for you guys to wrangle that amount of data and then be able to analyze and calculate the trends. Thank you both so much for presenting today. If you have any questions for Neala or Thomas, go ahead and either unmute yourself or type it in the chat, or raise your hand and we can call on you. And with that, I'll just open up the floor for you guys.
have one question for Neala and Thomas. You mentioned that you're hoping that you'll get more populations into the Coordinated Assessment Partnership. I was wondering if you've been hearing any interest from others that maybe we should be made aware of, so we could try and help them out if they're interested in starting to submit sometime in the future.
Neala, can I take a stab at that one? Yeah, so let's see. So I think in the Columbia, our agency started participating, and with really a focus initially in the Columbia Basin. And so I think it was a smaller lift for us to get data into coordinated assessments in the Columbia Basin. And one of the other things that made it easier is that our co-manager partners in the Columbia Basin were also already familiar with PNAMP, with coordinated assessments, and in many cases were submitters of their own data to coordinated assessments. So I know the Yakima Nation's done that. We benefited from data that they've provided, Nez Perce as well. And so that was already sort of set up. Those relationships, that awareness, that kind of thing was set up. I think, as Neala mentioned, I think when we think about, the data for listed salmon and seal populations in Puget Sound and Olympic Peninsula, let alone our unlisted populations, one, that data historically wasn't in coordinated assessments, and two, for the non-listed populations, like it, basically the only place where it existed was in our historical SASE database. And that database really just doesn't have the richness of data fields, the metadata, the definition, the data exchange standard, which is what makes it so usable. And so you look across data series and, there's a lot of variability, like in how data fields are being interpreted population to population. It just really makes it not very usable for an assessment like this. And so we're really hoping that some of that data can migrate into coordinated assessments for those other regions. I think one of the I'll call it a growing pain that we sort of became aware of in this process was that there was less familiarity on the part of some of the Puget Sound tribes with PNAMP and coordinated assessments. And there were reservations about data for watersheds that they co-manage suddenly appearing on this other reporting database. And so those are, I think those are policy issues. And, we have those relationships are of the utmost importance to us. And so I think we're working through policy channels to sort of sort that out. But Neala and I are very optimistic that we'll find a way to get more data shared in this forum for other areas.
And for the other areas, they're not maybe as policy laden, like Coastal Tribe or other non-ESA population that WDFW has. If you can flag those for us, that's something that we can also pull attention to, because occasionally if when StreamNet has some additional funding accessible through other non-BPA or even BPA, we'll try and direct those funds to the non-ESA to try and get it in, like when we get funding from IGFA. So if you have priority populations, share that with us, and then we can also kind of sync up when there's no policy issue. We can try and sync up on those as well. Just let us know.
Awesome. And I guess you just sort of made me think of one other thing. I think one of the things that really makes CA work well, if I look at the way we've aggregated data on this, as a state in the past for co-management, we've had sort of the database that was the public-facing one, and we'd have to come to a lot of agreement on numbers before things would get put into SASE or SCORE. And so if there wasn't yet agreement, or those conversations simply hadn't had time to take place yet, the default was just not to display any data, right? And an alternative that I think is really smart that CA did is create the ability for there to be multiple data providers, which means like it's great if everybody can agree on a number, but there's also a world where everybody can provide their numbers and then let analysts and others sort out what they want to use. So I think that was a really nice thing that was done in CA as well.
That's very interesting to hear. This is Mike Bannock with StreamNet, because in the early years there was just a single estimate that was given, and then we went to the multiple. Although we've kind of heard that the multiples cause trouble for some people because they're not quite sure which to do, and which is understandable too. But then, you know, you're giving the other side of it here, so that's really interesting for us.
Yeah, well, I can give you a couple more thoughts on that. So so I think one, the best value was a field that we used, and we hope we were using it right. I think we were, but we were interpreting that as basically for this population in this year, that's the best value of the multiple values from a single data provider. Now, what might be more challenging is if you have multiple data providers that designate a best value in a particular year, which one do you use? And so I think that's where I think the context matters. So as an analyst, if I were in a purely research setting, I might, you know, and I had a model that could accommodate multiple estimates, I might just simply use both data sets, right? And have two likelihood contributions, for example, one which used one estimate and one which used the other. And you know, we do that internally all the time. Like when we make spawning ground, when we make escapement estimates from mark recapture and red surveys and area under the curve, you can sort of get a better estimate by pooling the sources of information. So that's one context. A different context might be a much more policy context where it's, you know, it's really important that there be co-manager agreement because that number is going to be used for something that has a legal and policy context, like setting fishery seasons or allocating catch. And in that kind of case, you wouldn't want to just sort of blindly go forward, you know, picking and choosing which numbers you want to use or using both because, you know, you'd need to be attuned to whatever the policy requirement was for consulting and arriving at a shared understanding in that case. And so I think, but I guess if you're a database, displaying them all is a good thing. And the more meta fields you can use to designate what they are and why they're different, I think the better. So, you know, that knowledge is power. And then it's kind of on the users, you know, it's like the user agreement you guys have. It's the user's responsibility to uphold the user agreement for the data and to use it in a responsible manner.
Mm-hmm. Thanks.
All right, excellent. That was great, Nancy. Is there anybody else out there that has any questions?
This is Jen Bayer. I want to just poke a little bit at the participants here, looking for a reaction on the future directions brainstorm. I mean, as people who've been involved in PNAMP stuff, you know, we love to host conversations about a lot of things. And we're doing a lot with data standards, you saw from the task earlier, but I'm intrigued by some of the points here with respect to standardization of status assessments across entities. We've hosted some workshops along those lines in the past, and we would love to do more of that. And part of why we have this fish monitoring work group and these big meetings is to throw these ideas out there and try and get people's reaction. So I'm going to stop there and just see if anybody has anything else to add, like, hey, you'd love to do that, or that should be a workshop next year, or how do we, you know, or just I'll stop just looking for other reactions of these more about the methods and analysis topics here.
Hi, Jen. I'll respond. And thank you, Neala and Thomas. I kind of work at this from the other end of coordinated assessments and providing the data to coordinated assessments. And I don't necessarily do any of the status assessment part of it. So I'm not the person that from, you know, kind of my group, a research group and WDFW. But I do think that there's been a lot of discussion amongst us about just as you said, transparency and standardization and sharing and getting kind of a better understanding around how other folks are visualizing and using this data for assessments outside of what NOAA is also doing. So I do think that, Jen, that there would be much interest in talking more about this broadly, for sure. I just don't know positively that the folks from within my group are on this call. So I will definitely share this information.
Thanks, Kelsey. Casey. And I didn't mean to cut off other questions. Also, there was a lot of very detailed information in the presentation. So if someone's out there poised with a question about, hey, what did you do in step 10 way back there, for Thomas and Neala, please jump in. Sorry.
Hey, Jen, this is John Arterburn. I'll share a little bit of perhaps the other side of the equation on the standardization question. You've probably heard this over the years from me and others that, you know, there's real concern when it comes to standardizing things, particularly across a very large spatial area, that there's many good reasons why methodologies have evolved to be different in different areas. There's different rationales between why the data is being collected and what its uses are. There's real differences in population structures and logistics across the board. So standardization sounds really alluring as something that makes things easy, but in reality, there's lots of good reason to remain flexible, and I would caution against a lot of efforts to really push standardization because it often is not really functionally an approach that works across large landscapes.
John, this is Thomas Buhrens again. That's a really important point that you just made about standardization. And I think that's one that within WDFW we've wrestled with because, you know, you think about the spatial extent, the variability of watersheds, the local factors that influence how we do things across the span of the entire state of Washington. There a lot of the things you described are going on. And one of the things that Neala and I have kind of started to sort of gravitate towards is this idea that we shouldn't blindly push towards standardization of everything all the time, because that then leads to all the problems you described. But what we can do, or at least what we've been thinking about trying to do, is kind of trying to find what those least common denominators are. And so if we can figure out like what are the things, you know, how are we doing things, be it in monitoring or status assessments in one area and in another area, and we can kind of just compare the factors and the reasons for why we're doing things the way we are and identify least common denominators, then we may be able to standardize at least to an extent, because a lot of times what we found is that there are the reason things are done differently in different areas is a mixture of two things. There are some reasons that have really strong rationales, they're important, and we don't want to lose those by forcing unnecessary standardization. But there are also reasons that are just sort of happenstance and arbitrary, and those are the ones where if we can eliminate those lack of standardization where there isn't a strong reason for it and a strong need for it, then we can at least incrementally move towards more consistency across space. So I think that's kind of how we've been approaching it, is more of like a least common denominator approach.
Thomas, I really do appreciate that response, because I think that's smart, and I don't want to say that in no way, shape, or form can you ever standardize, because otherwise coordinated assessments wouldn't exist. But on the other hand, people need to take the time to consider other opinions and other thoughts and remain flexible as you move forward. And I guess that's my biggest, most important point.
Great point. Yeah, totally agree.
Excellent. Thanks, John. Is there anybody else out there who has any questions or comments, or if they have any questions for the task leads, the stuff you heard earlier? We can kind of talk about that too if you guys are curious or have questions. Devin, go ahead and unmute yourself.
Yeah, thanks. Quick question I just thought of on that after that discussion. Your metric on what was it called? Future status, I think it was. Yeah, future status metric. Did you guys look at historical data at all to see how that might have lined up with known abundance indices? Like, for example, did you test that metric, back in the early 2000s to see how reliable it might be to known values? Just curious as far as like, the confidence you might get when the public is reading into something like this.
Devin, sorry, can you clarify what?
I think I know what he means, Neala. Okay. Is what you're saying sort of did we go back and look at how well that future status would have predicted what actually ended up being the status five years in the future using historical data? Is that kind of what you're asking? Yeah. So we did not do sort of a future prediction skill test for that. I think, I guess a couple thoughts on that. One, we could have done that to try to bound how confident we were in those predictions, but the way that the GSRO, the Governor's State Recovery Office, wanted those categorizations, like we already had to drop a lot of the uncertainty, like the uncertainty in the trends themselves, a lot of the different levels of certainty. And so if it was just kind of quantifying how certain or uncertain that was a little beyond the scope that they wanted us to consider, but I think we could do that in the future. And the second thing is, I think that the type of model we were using, so multivariate state space models, they are a pretty sound way of making short-term predictions. I think that when you start to look at really long-term predictions, a lot more, it's almost, I hate to use this example, but it's almost like COVID forecasting. If you guys have looked at any of the forecasts for COVID cases over the pandemic, like over really short-term timescales, you can look at patterns and rates of change, and it allows you to make confident predictions over a couple weeks. But when you're projecting, many months in advance for COVID, or in the case of salmon, like decades into the future, different management changes that could occur, like are as likely or more likely to affect trajectories and environmental change that's outside of our knowledge, like regime shifts, climate change, et cetera. And so I think in short time scales, I feel like the predictions generally, the type of model that we use generally has pretty good performance over short time scales. And that's one of the reasons, in addition to the 5-year management time scales, that we kind of just chose to focus on a shorter time scale. I think, yeah, does that help answer the question?
Yeah, thanks.
All right, excellent. All right, if we don't have anybody else, or if you guys obviously come up with anything, after we leave this meeting, I'm sure that Thomas and Neala could answer your questions via email or a phone call. So Sam, if you want to advance to the next step slide. Yeah, there we go. All right, so there's several links for you guys to get involved in this group. You can join our listserv. I will drop the link in the chat. Right. And we also have the Microsoft team. So there's a wiki page on there. You just need to click, if you're part of DOI, you can click one link, and if you're outside of DOI, there's kind of a different way you need to go about getting in. Also, we'll send out a follow-up email next week with links to the presentation, the recording, task information. Feel free to contact me if you need any additional information. And Sam, if you want to advance one more slide. So to close out today, I would just like to give a big thank you to Neala and Thomas for presenting, to our fish monitoring core team and task leaders. They take time out of their busy schedules to help coordinate these activities and develop products to help managers and biologists throughout the region, and we really appreciate everybody kind of collaborating together. And that kind of wraps us up for today. The next meeting will be January 20th, same time, same place.